now that we've got this template up, grab a new template, and you're probably seeing how it proceeds. It's going to be almost a replica of the first one, right? Almost an exact replica of the first one. So let's just go through it really quickly. We're still testing mu. You got that, beautiful. You're still testing mu, awesome. Now, your average is not what on average we call 3 inches, but what we call 7 inches. That's the only difference. We're testing the same thing on a different measure. So that's going to look exactly the same. Beautiful. The hypotheses are going to look almost identical. Because, now, I want to make sure though. Are we still claiming underestimation? I think we are.
Yeah.
I think we are. I think we're still claiming underestimation because we're getting smaller numbers. Okay? Except for that 1 7.5. And I apologize for you guys that got in a little bit late. We didn't get a chance to do your data. And now that we've talked about it so much, I'm afraid to get your data because it might be biased, right? It might be biased. So let's just stay with the original raw data. As far as the errors go, they're going to be identical, right? Type 1's false positive, type 2's false negative. As Rory and Chris, I believe, were the ones that verbalized last time for us. They're going to be the same. Type 1's going to be, we say we're underestimating when we're actually not. Type 2 is that we say we're not underestimating when we actually are. And you can just, whatever you think the worst error is, you just ignore that. But nobody cares in that spot. How about that? Nobody cares because it's a silly little exercise in class just to run some t-tests. We'll actually run some meaningful t-tests next week. I'm going to have you guys timing a 100-meter butterfly race, which actually ties back to a Bend High School question that happened about 5 years ago. Still doing a t-distribution, because we're testing an average. Now, as you guys are dutifully writing up your statistics, I'm going to pull the screen down, kick my shoes. I'm going to pull the screen down, and I'm going to slap up a histogram and a box plot of our new data, of our 7-inch data. Because I want to make sure that we don't have any, Chris, again, your data point, if it's an outlier on it, might be, it might not be, who knows? So.
I'm way down there.
Well, let's see. Let's just see. Yeah, right, down there is okay, it's how far down there is it, right? How far away from the rest is it? I'm going to change these to L2. Oops, they're both box plots, my fault.
Yeah.
There we go. Good. Yes, I thought so too. I made an erroneous conclusion that it was going to look like a bell curve because I assumed that if whatever error you guys made with 3, you'd also make with 7. Now, God knows, it's such a small sample, who knows? But no outlier. Chris, your data, even though it was low, is not exceptionally low. Okay? If you want, you can finagle with the window a little bit to clean up. You can make more bars on your histogram. You're always welcome to do that, of course. Make the scale 1. That doesn't change it much. Make it 0.7 maybe. Yeah, it's almost a uniform distribution, which I can live with that. I can live with that. What I'm really concerned about, and I want to take one quick 2-minute aside before we wrap this thing up. You guys are going to be doing a number of non-parametric exercises in this class. You've already done a few. The bootstrapping project, the card trick, check the 5 black cards. Whenever you use Excel and you hold the F9 button down, I've got one planned for your last exam, I've got 3 or 4 planned for your project in 3 weeks. Whenever you're holding F9 down and letting data show itself to you non-parametrically, Brandon, when your question was, how do I get more trials if I can't afford it, you simulate them. Those are called non-parametric results. It's the way this class will be taught in 15 years, if I have anything to say about it. Because you don't have to make any assumptions about the data. I wouldn't even bother checking this graph. Because I check this graph to make sure there are no outliers. And to make sure the data is not completely skewed to the point where the average gets pulled away from where it should be. Non-parametric data says, let the data show you what the data shows you, and then deal with it on its own terms, rather than forcing it into some model. So a non-parametric wouldn't have a t-distribution. It wouldn't have a z-distribution, or an f or a chi-square. It would say, I'm going to make up a new distribution based on what the data just showed me. It's a very logical way of dealing with data on its own terms, as opposed to making it fit some other model. We're not there yet. We're getting there. More and more. Flight simulators have made it easy. Any kind of computer simulation has made it more believable to be used. So we're getting there. And now with handheld technology getting a little more ubiquitous, it's getting there too. Not there yet, though. So I'm happy with this. I don't see there's no data point that's extremely pulling the data left. I'm not that worried about it. I can live with this. Let's finish it off. Test statistic, p-value, conclusion, potential error. Get the hell out of here. Once again, a t-test. Just change up the few things that you have to change up. Make the null 7. Change your list to L2. I still think everything else is going to be less than, yes? Yeah, everything else is the same. Draw, calculate. Draw. Draw gives you exactly what you need, honestly. I do want to run calculate at some point because I want to see what your guys' average was. Oh, don't ignore that. That's my histogram. Well, we know you guys are going to get a rejection. I don't see any area, which means once again, 3.7, 3.8 standard deviations that way. There's your test statistic. There's your p-value. 0.028, pretty damn small. Get your step 7 and 8. What does it look like? Looks like you're underestimating 7 inches statistically significantly. AKA, hell yeah you are. Potential error? Always a type 1 with a small p-value. Always a type 1. So now, thinking of it as the guy at the carnival, the hand has stopped, right? Oh, I've got to rewrite these. The hand has stopped. There's no longer a question as to which one of these you should believe. The hand stops right here. With that p-value, the hand stops right here. What was your guys' average? What did you actually average on that one? 5.293. That's actually down significantly. Okay, that one is much more down than I would have thought. Well, yeah, actually that is, isn't it? Because you guys were off by 0.7 of an inch. Was that right, or was it half? 0.7 of an inch. If you extrapolate that twice, which is roughly what 7 inches is to 3, you're off by 1.4. No, it's actually almost proportional. You're consistently poor measurers. Well done, friends. All done. All done. I love it. No, it always happens. There's always noise around the estimates.
It would be a lot better if it was measured.
It would be a lot better if we estimated more in grade school. Maybe. We'll do more days on Tuesday. Yes, and I'll have all your grades squared away. I don't know why Madeline's not getting the keys. I'll figure that out and I'll get you guys grades. Even if I have to grade it myself, I'll do that too. That's fine. I'd rather give her the hours. Let's just do the first one so you can keep one for reference. Let's turn in the 7. Turn the one we just did. Maybe right here. And then, yes. Yeah, let's get you an in-class quiz. Thank you guys so much for being here. I appreciate you coming out in the snow. I do. And we got an in-class quiz, but I wish I gave you extra credit. Actually, most of you are here, which is fantastic. Wow. Oh, thank you. It's way more than I expected. I'm very, very happy. Thank you for being here. I'm glad to get out early too, which makes me even happier to get you out there safe.
Question.
Please. I am?
Yeah.
Have I always been? Have I always been? Have we talked before? With Vaisky? Like in my office? How do I not remember that? Jesus. Yes, email me. Email me and whatever your idea. And have we ever done like a long-term plan before? Okay, then why don't I just send me an email? Let me just clear you, Sterling, because obviously you've got the plan in place. I don't know why I say clear you long-term. Let me just do that. Make it easy for both of us. You got it, man. You got it. Thank you.
You guys could clear long-term.
A year. I can clear for a year. I mean, that's I clear as long as I can, which right now is till winter 2016.
Right. Yeah.
So, but that's I don't do that. Well, I won't do it for most students if.
That's crazy. I thought that was just normal to clear a year.
No. I mean, the problem is if you clear someone, suppose they're on second academic warning, and I just clear them all the way through. Well, then I'm setting up a failure because whatever the problem is that's got them on academic warning is not going to be fixed as they go through. So, but someone like Sterling, who I've already made a plan with, I can't remember doing it. It's terrible, but. Sorry. What you got, my friend?
So 4.7?
Yes.
What is the variable? Is that
T.
inches?
No, T.
Okay.
T. The variable's T. Right. It's a T score. So whatever the variable is here in 6, you write that first, and then the numerical. And what's nice about it is it'll tell you right here too, Gabe.
Right.
It'll tell you right there. Just you're copying the contents of that screen onto your template there. Very nice, friends. Love it.
So, Sean, you want to explain to me why it's easier? Why you say it's easier to just look at the graph instead of just going right to the calc?